Hello everyone, this is Revathi working as an assistant professor in the Department of Information Technology from SNS College of Engineering. In my today lecture series, we are going to see about a role play on the topic of Knapsack using branch and bound. Before that, you have to know about the Knapsack problem and also the branch and bound method. Here is the problem statement for knapsack problem. The input is given as n equal to 3 and the weight equal to 4 and the values of the each item is 1 comma 2 comma 3 and the weight of the each item is 4 comma 5 comma 1 and the output will be 3. The explanation will be there are two items which have weight less than or equal to 4. If we select the item with weight 4, the possible profit is 1. And if select the item with weight 1, the possible profit is 3. So the maximum possible profit is 3. Note that we can't put both the items with weight 4 and 1 together as the capacity of the bag is 4. The item with the weight will be selected as 4. Then the branch and bound method role in the knapsack problem. Branch and bound is an algorithm design paradigm which is generally used for solving combinatorial optimization problem. These problems typically exponential in terms of time complexity and may require exploring all possible permutations in worst cases. Then the branch and bound solve these problems relatively quick than the other methods like dynamic programming and greedy technique. Then the backtracking based on the solution works better than the brute force. By ignoring infeasible solutions, we can do better if we know a bound on best possible solution subtree rooted with every node. If the best in subtree is was then current best, we can simply ignore this node and its subtrees. So we compute bound for every node and compare the bound with the current best solution before exploring the node. Here is the example for knapsack problem state space tree. State space tree is nothing but tree representation of the problem. Here purple's nodes are ignored because of uh, ex- exploring the bound values, then red node are ignored because of infeasibility solution of the given problem. Let us see activity by our student. Thank you.
Now we are going to see knapsack problem with bound and branch. In that knapsack problem, we are going to see introduction. In knapsack problem, you need to pack a set of items with a given value and size into a container with a maximum capacity. This is called knapsack problem with branch and bound. Now we are going to see an example problem for knapsack problem with branch and bound. The first column is called items, the second column is weight, the third column is values, and the fourth column is V by W, value by the weight. In first column there are three items, item 1, item 2, item 3. Their weight is 4, 7 and 5 and their value is 40, 42 and 25 and their value by weight is 10, 6 and 5. Bound equal to V plus W minus W, Vi plus 1 divided by Wi plus 1. Now we are going to construct a graphical tree with branch and bound. Now we are going to insert an initial value first. It is V equal to 0, W equal to 0. The upper bound we included in this and we substitute the values for that values plus weight and Vi plus 1 and Wi plus 1. In this, the upper bound equal to 100. From initial condition, we are going to split into two nodes, with one, without one. The upper bound for with one is 76. The upper bound value for without one is 60. In this we are going to choose maximum value from two nodes. The maximum value is 76. In 76 we are going to split into two nodes, with 2, without 2. The weight of the node with 2 is 4 plus 7, it's called 11. It is not feasible, it is out of the range. Now we are going to choose without 2. The without 2 value is, upper bound value is 70. Without 2 node we are going to split into with 3 and without 3. The with 3 upper bound value equal to 69. The without 3 upper bound value equal to 64. The value of the Knapsack problem is 69.